I think so. I had not started sharing my screen on OBS. Now I think we are rolling. Let me start my desktop audio and let's view this. I would like to give shout out to Greg Hogg. I have
That's
subscribed
not a
to
stone
him.
at all, so we're just left with this stone. So that is what we'd return. Now the slow part of that algorithm is finding.
Let's start again.
Here's the great discovery, the law of three. The law of three says that no matter how many things you do, how many tasks you do in a week or a month, three of those tasks account for 90% of your value. You make a list of all of your tasks, and I do this with three magic questions. Magic question number one, if you could only do one thing on this list, one task on this list, all day long, which one task would have the greatest positive impact on your career? So you put a circle around it. Then you say, if you could only do two things all day long, which would be number two? And you put a circle around that. If you could only do three things all day long, which would be number three? Put a circle around that. And those three tasks are sitting there. Those are my big three. Everything else is secondary. Everything else can be done by someone else, or done later, or not done at all. And then you focus on the three. If you can do that.
NVIDIA loves this coding interview question. The problem is called last stone weight, and it pretends to be an easy, but it's definitely not. Given an array of numbers representing weights of stones, we are going to play this game. On every turn, we get the weights of the two biggest stones. We clash them together, and we're left with a stone that's the difference of their values. So we do it again, we take the 3 and the 2, that is going to give us a 1. But then when we take 2 of the 1s, that's not a stone at all. So we're just left with this stone. So that is what we'd return. Now the slow part of that algorithm is finding the maximum value.
So maximum value for every time you have to do this.
That is an O of n operation.
O of n into n square.
So the trick to this is to place all of the values in a max heap. If we heapify this at the beginning, we can pop off the max in log n time. So in log n time, we get our two max values, we smack them together.
Oh, this max heap was wrong, I feel. Max heap, here also there should be a value tree, but it must be almost complete binary tree. But he put it over here.
And then place that result onto the heap. We bash together the 2 and the 3, we get another 1. We bash together our 1s, and we're left with just this final value. Here's the solution in Python, but NVIDIA might want you to do it in C. NVIDIA loves this.
I mean, I would like to start something like this short form, but here my thinking capacity is not being experimented. It's just short form content to be consumed on. So not for today. Let's do it some other time. This method only submission. Eh? The function to merge sorted. This is a method only submission. You only need to complete this method. Okay, something I didn't understand. Given two sorted linked lists consisting of n and m respectively, your task is to merge both lists in place and return the head on the merge of the merged list. So since they have specified in place, I had thought of you giving the brute force approach as using another list node to store all the values, where the head pointers will keep track of the lowest value and substitute it in the new node being formed and increment the lower value pointer to the next. But since it is in place, um, let's see how we will do. But first by doing a dry run. So as we know our drill, we will start by doing a dry run on our piece of paper, and for that to be seen I use OBS Ninja, means video.ninja. So the focus is quite off. Let's disconnect and reconnect it. Oh yes, this is quite right. Now it's loading. Hmm, So its problem. Oh my god, such blur. How should I solve this? How will I solve this? What else can we do? Now is it right? Yes. I should have done this prior, but sorry. Even though it is in place, since we are iterating both the linked list, the time complexity would be around O of m plus n, where m is length of first linked list and the second linked list length is n. Merge to sorted LL. So how we are going to begin is by creating a linked list with two pointers each respectively. What example we will be using is 3 points to 7 points to 10, 1 points to 2 points to 5 points to 8 points to 10. Now how we begin is bring our blue pen out, and now this is our, what we will call this, H2 H1. We will So how we will begin is we will keep temporary variable as h2, and another result variable. Two pointers we have created comparing the first node of both, pointing one. So since h2 contains the lower value, we will point temporary and result to h2. Start iterating a variable temp will always be equal to none at the start of the iteration. So so what will happen is result is to pointing to the lowest value. Now we temp is pointing to the lowest value as well. So what will happen now is, since this iteration has done 1, 2, 5, 8, 10. Now H2 will point over here, result is pointing over here, H1 is pointing over here. So where is temp? Temp is currently over here. Now what will happen in the third iteration is 1, 2, 5, 8, 10. H2 will come over here because it is lower. Temp will come over here. Result will stay here only. H1 over here. So this is our first iteration, second iteration, third iteration, fourth iteration, 3, 7, 10, 1, 2, 5, 8, 10. Since H1 is greater than H2, temp dot next will point at this. So now since 5 is first very first iteration complete, now the temp is storing node is connected to the node pointed at L2 or link. So what driver is telling to make it H2 and this H1 and temp to null. Hmm. Hmm. So first dot next is equal to if first dot data is less than. So how I did it is point this to here. First dot next. Okay. Then this from, then temp is over here, then it will point, then again it will check from here. So which is the lower one? So it will again come over here. Now it is pointing over here. Now it will check from this two, which is the lower value. Then it will come over here. Then it will again go here. Then something like this. So let's go into implementation part. Are you guys able to see my coding screen? Oh shit. Let's begin by implementing our question. So the implementation is quite simple. How? We will first check if head 1 dot next or head 1 equals to none. If yes, just return. So this is a recursive call. So just return head 2. If head 2 equals to none, just return it on head 1. So why we are returning this? Because as in the case of the example of driver, if the we have reached end of either of these two, so the continuation, the next part should be pointing to the whole remaining part. So how we will do this is use while loop, while loop. No, we will check is head 1 dot data less than head 2 dot data. Head 1 dot next equals to sorted merge head 1 dot next or head 2. So what is happening over here? If head 1 is lower value, so the next value, lower value is found by recursively checking which one is lower, head 1 dot next or head 2. If head 1 is not lower, then head 2 dot next is equals to head 1 or head 2 dot next. But here there is one caveat. So what we will be returning? So we have to return head 1 because if array is something like this, first array and second array is this. So first this is the lower value. The next we'll call 10. So after calling the next to 10, the return statement is to call the head. So it will maintain the head. And in the recursive call, the head is now 10. So the next we are pointing to 11, but head remains the same, and we are returning it to the one whose next is 10. And now after this we are returning 1 as the main answer. This question is quite big brains. I am confident that it will return the intended answer. Yes, it did. So let's submit it and bada bing bada boom, jump into the next question. So the next question is that we are going to revise what we have done. Some few questions we will revise and meet tomorrow for the next questions. So we will be beginning by, should we do all of this? I mean, let's first submit this question. 100 to go and submitted in first attempt. Yes. I didn't remember this quite clearly because when I referred driver's solution, it confused me a bit. So the question over here is quite good. Let's check what Geeks for Geeks is providing. Oh my god. It's quite similar. See, here we are using the cursor. It's the same logic. This is quite similar, but content theory is very high. Let's skip all of this and revise the rotate matrix. Brute force approach. Let's begin by this. Take another dummy matrix n by n and take first row of the matrix and put the last column of the dummy matrix. So take second row. Acha, okay. Rotate image. So this question requires transposing transpose the matrix. Yes. Step 1, transpose the matrix. Reverse each row of the matrix. Okay. So for transposing, what's the logic? For int I, this is the reverse logic, I think so. Yes, it is quite simple. Yes, it is. Matrix of I of j. Then we are putting this value into of I of j. Okay, done. Reversing logic, transposing logic. So what is transposing logic? For I is equals to 0, j is equals to I. Temp here also they are doing swapping. But what are they swapping? I comma j with j comma I. Okay, transpose is simple. So for j I comma j is transposed with j comma I. I comma j is transposed with j comma I. This rotate image logic is quite different from what Coding Ninja is asking for us to do. This logic is quite a brain teasing question. So, have I done the question in my notes? I have done. So, transpose one was quite simple. Was transpose, then reverse. But the Coding Ninja question, they are shifting. One will come over here, two will come over here, two, three will go down, six will go down, nine will come on the left, then eight will go further left, then seven will go up, then four will go upper, and in the middle part it will be repeating again. So how we will start this is by reviewing our notes, because the Geeks for Geeks video explanation was quite good. So, oh my god, the video is blurred again. How can I do the explanation such a way? So, the first row does left right shift, the second last column does downshift, the first column does upshift, and the last row does left shift. So, this is an iterative approach where we will keep the previous counter value and do the shift here, now then shift over here. We are going to keep previous and current values counter, something like that. So see, we will begin by placing previous. Where is previous? Previous. Previous is equals to row minus one column. So this is the one. We will swap it over here. Then we will store the current value in previous. Then we will enter the loop where we will increment the column for the given row. The outer loop is for iterating the whole outer circle parameter. So let me show you the code. What is this? State matrix. Where is it? No, not coding ninja solution. One coding ninja solution. Chrome rotate matrix. Why is this not refreshing? Chrome browser 1, 2. Yes, we are over here. So I've not submitted over here. What is it? Matrix. So what is this problem called? Rotate matrix. Yes. So this loop is for the outer part. So first to iterate this outer part, then to iterate the inner part. So this is the inner loop. So if row plus 1 is greater than or equal to m, so if we have exceeded the indexing, we will break. Start the previous by fixing by a fixed value. So over here it will be 3 because column is 0, row is 0 plus 1. Okay, so previous is set, and now we will do the right shift by storing current value and what we say, updating it with previous and updating previous with current. After this we are incrementing row. Now what we are doing is that we are getting all the values of this column, last column, and doing the downshift, after which we are decreasing n minus 1 to show that the right part is rotated, and now we have to figure out for this part only the first two columns. Now we will check if row is less than the length of the row. The current position is less than length of row. We will do the right shift, then decrease the m. Why we are decreasing m? Because the lowest array, the means the lowest row is now rotated. Now we will do the shift of this 3 and 2 and then increment column. So this loop will continue until all the elements have been rotated. So to show you all one example, let's jump into the dry run. So see, this shift is happening, the current and previous are updated. Now again the current contains 2 and it will be updated by previous which is 1. Now and after which the previous will contain 2 and current will contain the next value, and it will go on. So not thinking more about it, let's go on to the next question, which is merge overlapping subintervals. Merge overlapping subintervals. What is that problem statement? Given an array intervals, merge all overlapping intervals and return an array of non-overlapping intervals. Okay, merge overlapping intervals. So if we go on to Geeks Code Ninja, so the brute force approach is quite simple. as they have given the information, uh, Ninja is playing with intervals. However, he doesn't like overlapping intervals, so you must help Ninja by merging all the overlapping. So, what are overlapping intervals? L left of 2 is less than or equal to right of 1. So, in this case, since you are able to see this screen, in Coding Ninja, they accept it. Okay, sorry, I confused this with the another question. The question was of reverse pairs and merge inversion. I'm just checking that reverse pair question. Yes, it is over here. So it was based on count inversion. Okay, where merge sort approach was used. Here, what approach they have used? Let's check. Merge intervals. So what was count inversion problem? If a I of j is greater less than, let's understand the question deeply. We are required to give total number of inversions, and the inversions are for I and j is less than size. If I is less than j, then you have to find pair a of I and a of j such that a of I is greater than j. So what intervals are? Have I not solved this? I don't think so. I have solved this question. I have not solved it over here. Hmm. So what they have done over here is the first element we pass it as it is and then get the right value of the element in the answer array. If the value of current left is less than or equal to the right value, we will update the right value with what current left or current right. Else what we will do is just simply add it. But in lead code there is something deeper. It's not accepting the same answer. And why is it so? Let's check. Arrays dot sort. Okay. Okay, so the difference is here the arrays is not sorted. Arrays dot sort arr. Let's have fingers crossed and try implementing. Okay, how do we sort a 2D array? So guys, little noise would be coming because let's say, I think the code should run all some. Eesh. So the problem was just that the array was not sorted in this case. Let's comment this out and check. Oh my god, such a simple situation. Okay, I will solve this tomorrow. Now this is done. Merge to sorted array without extra space. This is very simple. We will have a right pointer pointing to the right of left sorted array and another pointer pointing to the first array's first index, and we will do swapping until the left pointer is greater than means the left sub array value is greater than right sub array. So let's check if who is this driver has done it or not, a dry run or not. Hmm. Yes, see, the last pointers are used. They will swap and decrement it if it is lower. Means right is lower than left. So swap since 3 is lower than it. Again swap and increment decrement. Now since 4 is greater or lower than 9, stop. Simple as that. Mm, find the duplicate in array of n plus 1. Find duplicate in array. You are given an array containing n integers. Each integer in the range of 1 comma n minus 1, which exactly one array repeated in. Your task is to find duplicate element may be repeated more than twice, but so our just work is to find duplicacy. So we will keep a set and okay, so if we will check just if it is not there, we will add and if we find the duplicate, we will just return it. Quite simple. I mean, now I will using sorting. Okay, and login time, frequency, store frequency, and cyclic linked list method. This is quite intuitive. Uh, let's see this question tomorrow. Okay, bye guys. Thank you for being with me. Mm,